This video recording provides the steps to be followed for setting up Azure resources in an Azure subscription. These resources are created to host the SDR reference implementation. Legal disclaimer. These materials and information are provided by Translated Biopharma as is any party using or relying on this information, and these materials do so entirely at their own risk. Neither Translated nor its members will bear any responsibility or liability for any harm, including indirect or consequential harm, that a user may incur from use or misuse of this information. The recording covers the below steps: configuring Azure AD groups and users, deploying Azure resources using Terraform code, manual configuration of specific Azure resources, and verification of deployed resources. Log into Azure portal. The user should have global admin level of access to configure Azure AD groups and users. The first step is to do resource provider registration on the subscription for SDR infra deployment. Go to subscription and click on resource providers blade. And register the required providers for SDR infra. Register these four resource providers on this subscription. Search for Microsoft.network and register this provider. For this instance of SDR reference implementation, the providers have already been registered. Next step is creating the Azure AD groups for RBAC on resource groups and resources. Search and select Azure Active Directory from the search bar. Select the groups blade. Click on New Group. In the new group form, select the group type as security and provide the group name. And click on create. The group is created successfully. The list of groups in this guide should be created in the similar manner. To assign Azure AD roles to groups, Azure AD Premium P1 or P2 license is required. For the purpose of this recording, Azure AD free plan has been utilized. The groups contributor group, development team group, and testing team group will be later used in GitHub before deployment for providing access at resource group level using IAC code. Capture the group names for further usage in GitHub Secrets. The next step is to create the users to access the SDR application. Go to Azure Active Directory, Users Blade, click on New User, select Create User to create the user on the Azure AD tenant. In the Identity section, provide username and name. Optionally, add the groups for the user. Click on Create to create a new user. A guest user can be invited from the partner organization using invite external user. Select invite user, provide name and email address of the user. Add users to groups depending on the required level of access on resources or Azure subscription. Click on invite to invite the user. The user is successfully invited. In this step, the created groups and users will be assigned roles at Active Directory level and subscription level. To assign the roles at subscription level to the Azure AD groups, go to Subscription and select the Access Control IAM and click on Add Role Assignments. For adding role to the owner subscription group, select the owner role and click Next. In Members, select the owner subscription group. Click Next. Click on Review plus Assign to assign the role assignment. For adding role to the infra group, Select the contributor role and click Next. In Members, select the Infra group and click Next. Click on Review plus Assign to complete the role assignment. For adding role to the development team group, select the Reader role and click on Next. In the Members, select Development team group. Click on Review plus Assign to create the role assignment. For resource group level, role assignments are handled by Terraform IAC code. This step is to configure the prerequisites for Terraform IAC code deployment using GitHub Actions. First is to create a resource group and storage account for storing the Terraform state file. Go to Azure portal and launch the Azure CLI. If the Azure CLI is launching first time from Azure portal, it will prompt to create storage account. Select the relevant subscription and create storage account. Execute the CLI commands to create resource group and storage account for deployment. Provide resource group name. Provide storage account name. Provide resource group name here for storage account. Provide blob container name for storing Terraform state file. Provide storage account name. Execute these commands in Azure CLI. Second step is to create service principal. The service principal is to enable Terraform login from GitHub to deploy the resources. Execute this command on Azure CLI and capture the output. The output of this command will be used to log in from GitHub to Azure. Capture the subscription from subscription list in portal to add it on command. Provide the name of the service principal. Execute this command on Azure CLI. Capture this output to add in GitHub Secrets. After successful execution of command, this service principal should be provided user administrator access on Azure AD and user access administrator access on subscription level. To assign user administrator role, go to Azure AD and select roles and administrators and select your user administrator role and add the service principal that was created. To assign user administrator role on Azure subscription, go to subscriptions, select the subscription, select access control IAM blade, add role assignments, select user access administrator role, click next and select the service principal. Click on review plus assign. The next step is to add GitHub secrets that includes Azure client secret details and some architectural level configurations required for IAC deployment. Capture below secret values based on the environment design decisions and the storage account service principal details. Capture the name of the resource group that contains the storage account. Capture the storage account name. Capture the name of the blob container where the Terraform state file will be stored. Capture the client ID from the Azure Service Principal output. Capture the client secret. Capture the subscription ID. Capture the tenant ID. Provide the name of the Terraform state file. Provide the environment name. Provide the VNet address space. These are part of architectural decisions. Provide the short form of the subscription name, which will be added to the resource naming convention. Here we are providing it as SDR. Provide the publisher name. Provide the publisher email ID. And provide the name of the service principal. For this instance of SDR reference implementation, the secrets have already been added and this is a screen grab of the same. For adding secrets in GitHub, the user should have repo admin access in the GitHub account. There is a documentation available in setup guide on how to add secrets in GitHub. In the GitHub secrets, places which has special characters needs to be escaped to fetch the values. IP address space needs to be added as shown in the screen grab. After adding these secret values, run the GitHub workflow to deploy the resources on Azure subscription. To invoke the deployment, go to GitHub, select SDR platform repo, go to Actions, select CA workflow, click Run workflow. The output of the run can be seen in Summary console. The IAC code deployment will take approximately 40 to 50 minutes. The deployment has completed successfully and it took 56 minutes. The next step after deployment is to perform the manual configuration steps and capture the required details that need to be added on Azure Key Vault Secrets. Configure app registration on Azure AD for SDR, UI and API authentication. Go to Azure AD and go to app registrations. Select SDR Dev UI app registration. Go to expose an API blade and add scope. Click save and continue. Provide scope name. Select admin and users. Provide admin consent display name. And click on add scope. Capture the scope URL that need to be added in Key Vault Secrets. Now go to API permissions blade and add a permission. In the request API permissions page, select my APIs and select the UI app registration. Check the permissions and click on add permissions. Now grant admin consent for these APIs. Now the app registration configurations are completed. Capture the client ID and tenant ID in the app registration for adding to Key Vault. Capture client ID. Capture tenant ID. Capture applicant. Now create client secret in this app registration. and capture the value. Next step is update the path mapping of UI Azure App Service. In the portal, go to the UI App Service instance in the application resource group. Go to configuration blade. Go to path mappings and change physical path from /www root to /www root /SDR hyphen web app and click on OK and click on save. The final step in manual configurations is to add keyword secrets. These secrets are values from different resources that have been deployed and additional configurations done earlier. Now capture all the secrets values from the deployed resources. Provide API management base URL. Go to app resource group and go to API management. Go to APIs blade. Select API endpoint. Go to settings. And capture this API base URL. Now capture app insights instrumentation key. Go to app resource group. Go to application insights and capture the instrumentation key. Capture app insights API key. Go to app insights and search for API access blade. And capture the application ID. Capture the app insights API key value. Create API key and check read telemetry and generate key and capture this key value. Provide default app insights URL. Provide the Azure AD authority value. Add tenant ID here for this URL. Capture the UI app service URL. Go to apps resource group. Go to UI app service. Capture this URL. Provide the app service redirection URL. Capture the Cosmos DB database name. Go to apps resource group and go to Cosmos DB and go to Data Explorer. Capture the database name. Capture the Cosmos DB connection string. Go to connection string blade and capture the primary connection string. Capture the service principal JSON output which was created as part of GitHub Secrets. Before adding secrets on key vault, the logged in user should be given access to create secrets. Navigate to key vault. Go to core resource group and go key vault. Select access policies blade and add access policy for logged in user. Select logged in user and add and click on save. Next, start adding the secrets listed in the table. This list is also available in the deployment guide document. To add secrets, go to Secrets and click on Generate or Import and provide name of the secret. Enter the secret value and click on Create. The secret has been created successfully. The list of the secrets in this guide should be created in the similar manner. For this instance of SDR reference implementation, the keyword secrets have already been created. There are steps available in Platform Setup Guide on how to add keyword secrets. Now the ESC code deployment and resource configuration has been completed. To validate the resources have been deployed and configured correctly, the low-level design document LLD can be referred and verified against the resource configurations. For verifying the VNet configurations as seen in the LLD, go Azure portal and go to resource group and go to core resource group and select VNet. Compare the values for each setting in the portal against the LLD. Check deployed VNet in correct subscription. Check VNet deployed in correct resource group. Check the VNet name. Validate the region. Address space. Validate the tags. Validate the diagnosis settings is enabled or not. Validate the log analytics workspace. Similarly, the remaining resources configurations can be verified.